This is Mrs. Appia with Lesson 12, the scale factor as a percent for a scale drawing. Student outcomes for this lesson. Given a scale factor as a percent, students make a scale drawing of a picture or geometric figure using that scale, recognizing that the enlarged or reduced distances in a scale drawing are proportional to the corresponding distances in the original picture. Students understand that scale factor to be the constant of proportionality. Students make scale drawings in which the horizontal and the vertical scales are different. In Module 1, you were introduced to proportional relationships within the context of scale drawings. Given a scale drawing, you identified the scale factor as the constant of proportionality. You compared the scale drawing by the original drawing to determine whether the scale drawing is a reduction or an enlargement of the original drawing by interpreting the scale factor. You calculated the actual lengths and areas of objects in the scale drawing by using the scale factor. In this module, lessons 12 through 15 build on what you learned in Module 1. These lessons require you to create scale drawings when given a scale factor as a percent, or to determine the scale factor as a percent when given the original drawing and the scale drawing. You'll make scale drawings in which the horizontal and vertical scales are different. You'll compute the scale factor of several drawings with different scales, determine actual lengths from scale drawings, and solve area problems using scale drawings. Although these concepts may seem similar to those covered in Module 1, this module emphasizes the connection between percent of change and the rescaling of figures accordingly. It's also important to note that the scale factor may be still written as a ratio, as in 1 to 5, 1 to 5, or 1 inch represents 5 inches. This module includes an examination of horizontal and vertical scale factors. It's important to note that if only a scale factor is named, we conventionally apply it to both the vertical and the horizontal measures unless otherwise stated. Copy the essential question for Lesson 12. How do you calculate the new measurements for a scale drawing? Here we have a snowman. Notice that the body in the middle is the original size, and the horizontal distance across the neck area is 3 units, and this length is 4 units. Then the distance in Figure B going across the top here is 4.5 units, and this distance is 6 units. And for Figure A, the distance going across the top, which is the horizontal distance, is 1.5, and the vertical distance is 2. So make sure that you understand the difference between vertical and horizontal, as we'll be using those terms. Compare the corresponding lengths to Figure A to the original octagon in the middle. This is an example of a particular type of scale drawing called a reduction. Notice that the smaller part compared to the original is called a reduction. It's called a reduction because the corresponding sides are reduced, smaller than the original. For example, the original was 4 units along the side, and the reduced size is 2 units along the side. Compare the corresponding lengths of Figure B to the original octagon in the middle. This is an example of a particular type of scale drawing called an enlargement. So Figure B is larger than the original. The horizontal distance is 3 units in the original and 4.5 units in the enlargement. And the vertical distance is 4 units in the original and larger, 6 units in the enlargement. An enlargement is called such because the corresponding sides are enlarged, or larger than the original. Using the diagram, complete the chart to determine the horizontal and vertical scale factors. Write the answers as a percent and as a concluding statement using the previously learned reduction and enlargement vocabulary. First, we'll do the horizontal for Figure A. So the horizontal length for Figure A was 1.5, and for the original was 3. So we'll write that as our scale factor. So we have 1.5 in our numerator and 3 in our denominator. And we want to write that as a percent. So 1.5 over 3 is equal to 1/2, and 1/2 is equal to 50%. Then we'll do figure B. So taking a look at figure B, the amount for figure B is 4.5, and then the original is 3. So we have 4.5 for the new amount and 3 as the original amount. And 4.5 divided by 3 can be simplified, and we can write that as 1.5 over 1, and that would be 150%. Next, we'll be calculating the vertical measurement. The vertical measurement for the original is 4, so that will be our denominator in both cases. The numerator is the vertical length in figure A, which is 2, and the vertical length in figure B is 6. And we want to simplify that. 2/4 is equivalent to 1/2, and that is equal to 50%. 6/4 is equivalent to 1.5 over 1, which is equal to 150%. For our concluding statement, the top is a reduction of the middle. It is 50% of the corresponding length of the original drawing. Figure B. The bottom is an enlargement of the original. It is 150% of the corresponding length in the original drawing. The quotient of any length in the scale drawing and its corresponding length in the original drawing is called the scale factor. So understand that a quotient is a division problem, and that's why we have a numerator and a denominator in our scale factor. Also, notice that the scale drawing is the numerator and the original drawing is the denominator. Use what you recall from Module 1 to determine the scale factors between the original figure and figure A and the original figure and figure B. The length in the reduction is our numerator, and the length of the original is our denominator. And I can take these numbers from right up here. We had 1.5 over 3, 1.5 over 3, and that's simplified to 1/2. And so our scale factor is 1/2, and that is for figure A, which is a reduction. And then figure B, we have the length in the reduction is the numerator, the length in the original is the denominator. We've already done that up here, and we had 4.5 over 3. And 4.5 over 3 simplifies to 1.5 over 1. So our scale factor is 1.5 over 1. Again, the scale factor is written as a fraction here, and in the above section we were asked to write the scale factor as a percent. So the scale factor can be written either way. In this segment of lessons 12, 13, and 14, we'll be focusing on the scale factor as a percent. Example 1. Create a snowman on the accompanying grid. Use the octagon given as the middle of the snowman with the following conditions. So if we scroll down to the middle here, we say, to create the head of the snowman, make a scale drawing of the middle of the snowman with a scale factor of 75%. So the head of the snowman will be 75% of the middle. And then it says to create the bottom of the snowman, make a scale drawing of the middle of the snowman with a scale factor of 125%. To find the new length, you multiply the scale factor times the actual length. Go ahead and copy that into your notes. So the first thing that we need to do is to calculate, or just to count, what is the width on the neck and the height for the given figure. So we're going to measure the width from the widest from left to right. So that will be measuring here. And then we also need the neck, the top from left to right, which we'll measure here. And then also the height, and that's the tallest from top to bottom, so we'll measure that here. So go ahead and pause the video and count those numbers. So I've counted the numbers, and the width of the snowman at its widest is 20 units. The neck is 12 units wide, and the height is also 12 units. Then, to create the head of the snowman, what we want to do is we want to take the width, which is 20, and it wants to be 75% of that. So we multiply that by 75%. And you can do that two ways. You can either use your calculator percent key, or you can convert that to a decimal, but do one or the other, not both. If you used a decimal, then you would use 0.75. If you use your percent key, you would enter 75 second percent. And then that is going to give us our new amount. Then for the neck, which is 12 units, we also want 75% of that, and that's going to give us the width for our neck, and then the height. And since it's also 12 units, it will be the same answer. Okay, pause the video and calculate those answers. All right, so we have 15 and 9 and 9. The next section is for the bottom, and this is going to be 125% of the original. So we have an original of 20, and we multiply that by 125%. The neck was 12, multiply that by 125%. And the height, which was 12, and multiply that by 125%. Pause the video and complete those calculations. And the dimensions that you should have come up with are 25, 15, and 15. Next, we'll go ahead and draw those, the head and the bottom of the snowman. And I know that it's going to be 9 tall. So I don't know if you noticed, but we didn't calculate this amount right here on the side. So let's go ahead and do that just really quickly. We have 1, 2, 3, 4, and it needs to be 75% of the 4 units. So 4 times 75% is equal to 3. So this is actually just going to be 3 units right here. 1, 2, 3. And I need to move that over a bit. All right, so we've got the head done there. Now the next thing is to draw the bottom part, and it's going to be 25 wide. So at its widest is 20, and I know the height of it is going to be 15, and then the width of it will be 15. So, and again, they didn't have us calculate this amount, so we know that it's 4 units, and 4 times 125%, or 1.25, is equal to 5. So this is going to be 5 units tall here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then this segment will be the same length. And then I'm going to connect the diagonals. And the purpose of this is not to draw a perfect snowman. The purpose of this exercise was simply to practice calculating the amounts. So we've done that. And again, what we did is we want 75% of the distance, so we multiplied by 75%. And then for the bottom, we want it to be bigger, 125%, and so we multiplied all of the dimensions by 125%. So don't worry if your snowman does not look perfect. That's okay. All right, is the head a reduction or an enlargement of the middle? 75% is a reduction. Is the bottom a reduction or an enlargement of the middle? The bottom is 125%, and that is a enlargement. What is the significance of the scale factor as it relates to 100%? What happens when such scale factors are applied? Well, if the scale factor is exactly 100%, then that will be the same size. If your scale factor is less than 100%, what do you think it will be? It is a reduction. And if the scale factor is greater than 100%, it will be an enlargement. All right, for example 2, create a scale drawing of the arrow below using a scale factor of 150%. Step 1 will be to label your measurements. Step 2 is to multiply each length by 150%. And Step 3 is to draw the enlargement. Pause the video and go ahead and complete this exercise. Resume the video when you're ready. So I've counted each of the amounts and I've multiplied them by 150%. So I know now that my size of my arrow, the enlarged arrow will be a segment of 3 units here, 6 units here, 6 units here, and 18 units going across. So if you haven't drawn your arrow yet, go ahead and do that now. So I've almost completed the arrow. I just need to connect these with a diagonal. And again, this section is 3 units, this section is 18 units, this section is 6 units, and this section is 6 units. And then I just connected these two sections by drawing a diagonal line. Example 3. Scale drawing where the horizontal and vertical scale factors are different. Sometimes it's helpful to make a scale drawing where the horizontal and vertical scale factors are different, such as when creating diagrams in the field of engineering. Having different scale factors may distort some drawings. For example, when you are working with a very large horizontal scale, you sometimes must exaggerate the vertical scale in order to make it readable. This can be accomplished by creating a drawing with two scales. Unlike the scale drawings with only one scale factor, these types of scale drawings may look distorted. Next to the drawing below is a scale drawing with a horizontal scale factor of 50% and a vertical scale factor of 25%. Okay, so the horizontal scale factor going across is the 50%. And then the vertical scale factor, which is the one that's going up and down, is 25%. So notice that the picture or the image is distorted. It does not look the same as it did originally. So the horizontal distance, that's the distance that's going across here. And it says that the horizontal lines are 50% of the original. So while this original distance here was 8 units, the new distance is 50% of that, which is 4 units. So we have 8 units times 50% equals 4 units. Then the vertical distance of the house, and that is shown in the green. So the vertical distance of the house is 8 units. And the vertical distance is 25% of the original. So we have 8 units times 25%. 25% times 8 is equal to 2. So the new vertical distance is only 2 units. Then we have the vertical distance of the top. Let's show that in red. So the vertical distance of the top is 4 units. And vertical distance is 25%. So 4 times 25% is equal to 1. So the new vertical distance is 1. I just want to talk about exercise 1. It says create a scale drawing of the following using a horizontal scale factor of 183.33% and a vertical scale factor of 25%. So if we were going to complete this exercise, what we would do is we would count the vertical distance going across and we would multiply that by 183.33%. And then we would count the vertical distance here and we would multiply that by 25%. And then we would use those dimensions to draw the new figure. Our distance going across is 6 units. So 6 units times 183.33% is equal to 11. Then our horizontal distance is 4 units, and 4 units times 25% is equal to 1. So the new dimensions of our figure will be 1 unit tall and 11 units wide. So notice that your new figure is distorted compared to the original. When you have a vertical and a horizontal scale factors that are different, your new figure will be distorted. In exercise 2, Chris is building a rectangular pen for his dog. The dimensions are 12 units long and 5 units wide. So this is our length, which is 12 units, and this is our width, which is 5 units. Chris is building a second pen that will be 60% the length of the original and 125% of the width of the original. So regarding the 60% of the length, will that second pen be longer than the original, and how do you know? Well, 60% is less than 100%, so it will be shorter than the original, or less long. And then 125% of the width. Will the second pen be wider than the original, and how do you know? Well, if it was 100%, it would be the same width. And if it's over 100%, it will be an enlargement, so it will be wider. So this pen is going to be wider, but not as long. Pause the video and write the equations to find the new length and the width using 60% of the length and 125% of the width. Resume the video when you're ready to check your equations and your answers. So we have 12 times 60% is 7.2 units, and for the width, 5 times 125% is equal to 6.25 units. When a scale factor is mentioned, assume that it refers to both the vertical and the horizontal factors. It will be noted if the horizontal and vertical factors are intended to be different. Can a scale drawing have different horizontal and vertical scale factors? If it can, how do you create a scale drawing with different horizontal and vertical scale factors? Well, we see in this example above that you can have different scale factors. So you apply the scale factors to the appropriate side lengths. For example, if you're given a horizontal scale factor, you use this to change the length of all the horizontal sides. How are the corresponding lengths in a scale drawing and an original drawing related? The corresponding lengths should be proportional to one another. The lengths of all sides in the new image are calculated by multiplying the lengths of the sides in the original by the scale factor. How does the scale factor relate to the constant of proportionality that we have been studying? The scale factor is the constant of proportionality. And that concludes Lesson 12.